A die is rolled twice. What is the probability of showing a 1 on the first roll and an even number on the second roll? All right, so let's see how we can organize this. Let's see, a die is rolled twice, and I'm assuming that's a six-sided die that's fair. So the outcomes on the first trial, the first roll, would be 1, 2, 3, 4, 5, 6. Okay. And out of those, what would be considered successes or favorable outcomes? The only thing we want is the number 1. So what is the probability of success in that first, let's say, let me say it this way. Let's see. First trial, organize this a little better. Let's say this is the number of outcomes. And we have the number of successes because event A is roll 1. So the number of successes is 1. So the probability of A would be equal to 1 out of 6. Which equals 0.16667. And then we go on to the second trial. So the next roll, the outcomes, again, are 1, 2, 3, 4, 5, 6. And B is the event roll an even number of dots. So the number of successes, did I spell that right? Anyways, successes. The number 2, the number 4, and the number 6 are all even. So the probability of B, given that A already occurred, okay? Now, if I rolled a 1, if A already occurred on the first roll and I rolled a 1, am I still able to roll a 1 on the next roll, or is that option out? Does that mean that I have a different probability when I calculate the probability of an even? Well, I mean, 1 isn't even an even number, but yes, I still have 6 options. If I had left out the 1, I would only have 5 options, so I would calculate 3 divided by 5, 3 successes out of 5 remaining options. But since these are independent trials, right, you don't take that side off the die after you roll it on the first. So there are 3 out of 6 possible ways that I could get a success on the second trial. So we know that's 0.5. Okay, now this is successive trials, so I need to use the multiplication rule for multiple trials, right? So the probability of A and then B is equal to the probability of A times the probability of B given A. And so, oh, it doesn't like my equals here. I'll just put an apostrophe in front of it. And so the answer is this probability times this probability. So my answer is 0.0833. I'm going to go to 3 significant digits, not counting the leading 0. So that should give me, yay,